We're about to start chapter 4 of the trigonometry textbook. As you can see, this chapter is titled Graphs of the Circular Functions. However, as mentioned, we're pretty much going to be ignoring this term circular function. And so what you can do is, as we're going through the textbook, every time this term circular function comes up, you can replace that term in your head with trig function evaluated in radians. Now, as we talked about in the previous section, the way that trigonometry defines circular functions, it's technically not the exact same thing as just a trig function evaluated in radians, but the two are very close. I would say it's completely fine to refer to this term circular function when it's mentioned in your mind as just a trig function in radians. So in this chapter, we're studying the graphs of the trig functions. And all of the trig function graphs that we study are going to be based on an input angle that's in radians. Now, I want to note that it's not like if we graphed trig functions in some unit other than radians, like degrees, that we would get some drastically different graph. No, not at all. An angle is an angle no matter what unit it's measured in. So if we graphed the sine, cosine, tangent, etc. function in radians, degrees, gradients, etc., and compared the graphs, they're going to have the same shape, the same features, the same properties, regardless of the units. And actually, as we go through this chapter, I'll show you examples of that. I'll show you a graph of the sine, cosine, tangent function in degrees, just so you can take a look. However, in the same way that radians simplifies trigonometric formulas, relations, equations, etc., that same effect comes into play with trig function graphs. So, for example, in calculus, the derivative of sine in radians is cosine, and the derivative of cosine is minus sine. That's related to the slope of the trig function graph. In radians, the slope of the sine graph at some angle theta is the value of the cosine graph at that same angle, right? So just with radians, there's more symmetry. Everything is simpler, cleaner, both in relation to formulas and the graphs. Now, all of the trig function graphs, all 6, they're all important. We want to study each in detail. It'll help us understand the functions better, how the function behaves, just give us more intuition behind the trig functions. However, the graphs of the sine and cosine functions in particular are definitely in their own special place. They have a higher degree of significance than the other trig function graphs. So we really want to make sure we understand the graphs of the sine and cosine functions. And that's what we're going to look at in the first 2 sections. So why are the sine and cosine function graphs so important? Well, if you remember back to some of the introductory videos to this course, I talked about the kind of the primary points or topics that are taught in trigonometry. The pillars, you could say, the headline bullet points of trigonometry. There were 3 or 4 of those, and one is the graphs of the sine and cosine functions. Okay, so the pillars were just the general definition of trig functions, right? And included with that, you could think about the unit circle is kind of like an offshoot of the general definition. Okay, and then understanding how trig functions are related to right triangles, how to operate with trig functions in right triangles, so solving right triangles. But more than just actual geometric right triangles, that's one part of it. But the vast majority of systems in all of physics, engineering, etc., are based on Cartesian coordinate systems. So here's a 3D Cartesian coordinate system. Okay, well, these are also known as rectangular coordinate systems. They're rectangular because everything, the positions of points, the components of anything, a velocity, whatever, it's broken down based on right angles, rectangles and rectangular prisms. So to get components, to break things down in a Cartesian coordinate system, you use trigonometry. And that's why when we think about the general definition of trig functions, It includes, you can have angles that result in negative components, right? You can have negative directions, things like that. Any angle, 0 to 360, you could have something facing down here, right? Based on an angle that's greater than 180 degrees, whatever. Okay, another pillar was how trig functions are related to a circle. Circular motion and anything circular, when you think about a circle, you can think about trig functions. And in fact, as we go through the graphs of sine and cosine sections, we're going to be thinking about the intimate relation of these two trig functions to the circle. So from that perspective, this section actually incorporates two of the pillars. Okay, but the fourth pillar is the graphs of the sine and cosine functions. Okay, so let's take a look at an image inside of section 4.1. Okay, here's a piece of a sine function. And so you can see here, we study its direct relation to a circle. Okay, but this pattern here continues all the way to negative infinity and positive infinity. This pattern repeats forever, both to the right and to the left. Okay, so it's like something like that. And cosine is very similar. It's just like a shifted version of this. Okay, this pattern here that sine and cosine have, which is called a sinusoid, a sinusoidal pattern, is extremely important in physics, engineering, etc. Extremely important. You could argue that this pattern here is as fundamental to nature, science, math as the circle is, which makes sense because of how directly related to the circle it is. Okay, so it's really important to understand the graph of sine and cosine in great detail. How to graph it, all of its features, how to shift it, transform it, what everything means. So in the opening two sections of this chapter, this is what we're going to study in detail. Okay, but again, we're also going to study the graphs of tangent, cotangent, secant, cosecant, which is not as significant as the graphs of sine and cosine, but it's good to understand the graphs. It helps us to understand these trig functions, how they behave. Okay, so in the next video, we're going to get started with an introduction to the graphs of the sine and cosine functions.